I've dedicated my life to exploring the unknown. I've been places no one else has ever gone. I've seen life no human eye has ever seen. It's my passion. I found the Titanic. I survived crushing depths and a rogue wave. But even after 50 years at sea, I'm as fascinated with the deep as I was on my very first expedition. You want to know my most important discovery? Well, it's the one I'm about to make. I'm Dr. Robert Ballard. Come with me into the alien deep.
Starboard engine is ahead, 20 RPM.
This is pilot. Yes, you ready to go? Roger that.
All right, here we go, guys.
Dr. Robert Ballard is convinced that life arose at the bottom of the ocean, in one of the most extreme places on our planet. And he's setting out to prove it.
We have ships all over the world. In fact, I'm in constant satellite contact with NOAA's ship of exploration, the Okeanos Explorer. Now, this is the Interspace Center calling the Okeanos Explorer. Do you hear me? Over.
Interspace Center, this is the Okeanos Explorer.
The Okeanos Explorer is heading to the Pacific, looking for the emergence of life on deep undersea volcanoes.
On the other side of the world, we have an Irish team on a research vessel, the Celtic Explorer.
We've got a target in front of us.
They're investigating a part of the Atlantic no one has ever seen before.
Ballard thinks this site in the Atlantic could be a huge geological factory that keeps life going on our planet.
You get to do this sort of thing once in a lifetime.
We have another team in the wildest ocean in the world, the Antarctic.
We know there is a big vent site here. It's chucking out lots of black smoke.
And I'm headed to one of the most dangerous undersea volcanoes on our planet. So what are we doing? We're trying to find out why this amazing planet of ours is just right for life. And I'm convinced the answer lies in the dark, deep ocean.
Over 30 years ago, oceanographer and geologist Dr. Robert Ballard stumbled upon a form of alien life where he had been told it could not exist. Until that point, all life was thought to rely on energy from the sun.
And that was the food chain, and we were led to believe that's it.
But Ballard was part of a team that discovered a different kind of food chain, deep, where sunlight could not penetrate.
We find a system that's completely operative in the total darkness of the deep sea, and that the life-giving energy is not the sun, but the energy of the Earth itself. We threw out all our biology books and started all over from there.
The life forms Ballard discovered were thriving at sites known as hydrothermal vents. These vents arise when water that has seeped into the seafloor is superheated to many hundreds of degrees by hot magma. Working its way to the surface, it forms roaring chimneys of hot, black water. Ballard's find turned biology on its head. Now he's out to prove that these extreme conditions were ground zero for life on our planet.
So this is maybe a laboratory to better understand how it all began in the first place.
The NOAA ship Okeanos Explorer is transiting the Panama Canal. It's heading out into the Pacific to the very same hydrothermal vent area where Ballard discovered life in the deep back in 1977.
Winch, Dr. Permission to start the winch.
Roger, starting winch.
Hey, we got the bottom on sonar.
Yes, we do. The bottom on both sonars.
That's great, thank you.
Science expedition leader Tim Shank has also been here before, and he knows the area is rich with life.
It wasn't just a few animals here, it was massive animals. I mean, clams the size of dinner plates. I mean, huge fields of mussels, groves of tube worms that were 10 feet tall. I mean, no one could have imagined that.
Hammerhead shark. Wow. It was a hammerhead shark.
Six years ago, a massive volcanic eruption covered the vents in fresh lava.
Right now, what we're doing is looking between the rock margins.
So this is now a fantastic opportunity for Shank to find out if life rebounds and how quickly it adapts to new conditions.
And it's very dynamic. There's magma moving underneath it all the time, and there's crustal cracking and deformation that's happening. They're changing on the order of seconds to minutes, hours to months.
Current depth is 595 meters.
Shank's been up for 2 days straight, and he's found very few signs of life. Ocean research is painstaking work.
I'm exhausted, physically drained actually, because I'm trying to locate sites on the seafloor. But maybe there's been a volcanic eruption in this location as well, and now it's covered up the site we were looking for. We really don't know. I'm gonna probably collapse because I've been on the edge of my seat all day trying to find this site, doing the best we can.
It's a lot more hard bottom here than I thought there was going to be.
So far, the team has failed to locate any new vents or life forms living in the lava fields. But for Ballard, this is only one site among many. And he's convinced that where there are volcanoes, there must be life. To him, the place to prove it is one he became obsessed with as a geology student: the North Atlantic seafloor.
When I saw this, it brought order to chaos. Because you could see that the beautiful thing about the North Atlantic is it's symmetrical about the mid-ocean ridge. You got a continent here, you got a continent here. You've got continental shelves, continental slope, continental slope, continental rise, abyssal hills. There's beautiful symmetry.
And right in the center of that symmetry is what's known as the mid-ocean ridge. It's a giant crack in the seafloor caused by the constant separation of the planet's great crustal plates. It runs around the entire Earth like the seam on a baseball, and it oozes the Earth's blood, red-hot volcanic lava. The plates move incredibly slowly, but there is a place on Earth where their separation can be seen. Iceland, where Ballard has come for a unique swim in freezing, crystal-clear waters.
Boy, that's truly amazing. I'm literally at the boundary of creation in Iceland. On my left is the North American plate right here. I can put my hand on North America. I can reach over here and put my hand on the Eurasian plate. And this is the very spot where the Earth is spreading open, about an inch a year, about your height in your lifetime. Iceland's incredible. It's part of the mid-ocean ridge that's been pushed up from the ocean bottom by a giant volcanic hotspot. It's one place on the Earth where you can go and see what it's like to be on the bottom of the ocean, but you're still on the surface.
Iceland graphically reveals what the mid-ocean ridge is like. Highly volcanic.
What people don't realize is that our planet is riddled with volcanoes, but they're almost all hidden beneath the sea. Literally thousands of them down there.
Because the mid-ocean ridge is so volcanically active, it's covered in countless hydrothermal vents. The very places Ballard thinks life on our planet arose.
You know, hydrothermal vents aren't just somewhere where there's weird tube worms and giant clams living. Without deep ocean vents, I very much doubt we'd be here today.
If Ballard's other team, out in the middle of the Atlantic, is lucky, they might just help prove that claim. But right now, before they can begin searching for new hydrothermal vents, they're struggling to even reach the site. "2,000 kilometers south of Iceland, the Irish vessel Celtic Explorer is arriving over the mid-ocean ridge at 45 degrees north. The team has had a grueling 1,600-kilometer journey.
When we headed out, the weather that we'd hoped to miss, we went straight into it. So we got quite a battering. We were rolling around a lot. Some of the stuff on deck started to shift a bit. People suffered a little bit from seasickness. Wasn't very pleasant, but it's much better now. We're much nearer the site.
The spot Andy Wheeler is seeking was first identified a few years ago when his colleague Bram Merton was passing over it on another vessel. The ship's water sensors sniffed a powerful scent, and as a geologist, Merton immediately suspected they were picking up the chemical signature of hydrothermal vents.
What you don't realize is right below us, and it's only 2.5 kilometers down, is this entirely different landscape. Plate tectonics is generating this mountain range. Big cliffs, fissures. You could go across a fissure and you look down at this gaping crack. You can't see the bottom. It's 50, 100, 200 meters deep.
So 10 kilometers, 10 knots.
This part of the mid-ocean ridge is mountainous, but scientists have long thought it was fairly inactive.
Well, the data the team has suggests otherwise. There could be some very powerful vents down here, and if there are, it's a vital part in understanding how our planet works.
The sonar scans of the ocean floor from previous expeditions were blurry and indistinct. So the team rescans the area in high definition. The scans prove that they've ventured into a landscape as alien as the moon.
It was just as I would imagine Neil Armstrong when he stepped out of that lunar lander. He just looked across this grey landscape. I just got this great sense of no one has ever seen this before. No one's ever been here before.
Far from being a dead, lifeless ridge, this could be nothing less than one of the primary pistons in the planet's machinery for life.
And that's why we're here. We're here to learn about how the Earth is not only creating itself, but how this process of creation led to the creation of life on our planet, and why it sets it apart from other planets in our solar system.
But as the team deploys the ROV, they're in for a nasty surprise. After paying out 3,000 meters of cable, Wheeler, Merton, and the rest of the Irish team quite literally reached the end of their rope.
we've come down to the bottom of the cliff and we've just entered a domain of thick black smoke, so thick on occasions we can't even see a foot in front of us. We're right on top of a very powerful chimney. It's pumping out extremely black, smoky water, and we're right on the very edge of our wire. We've got as much wire out as we can put out.
The team decides to take a risk. Usually, they leave 70 meters of cable on the winch as a safety measure. But today, they cautiously pay out 30 meters of it.
It's incredibly frustrating right now because we just got 3,000 meters down, another 20 meters to go. How close can we get?
Go again? Do you want it to go again?
Just like that, from making a big discovery.
We're straining on the leash here.
I've been in this situation more times than I want to remember. Deep ocean exploration is not for amateurs. Unbelievable pressures, freezing temperatures, a world of eternal darkness. You're limited by what your equipment can do, limited by your budget.
I've got an electronic drum kit set up here, and that's kind of a little personal pressure valve for me. So if I'm feeling stressed and I'm feeling angry and frustrated, and it's coming here to hit the man of the drum kit and then come back to yes, so that's really good. Calmly wait for the dive to go on. But at the back of your mind is always this kind of worry: is this it? We come all this way, and they're just a little bit too far down, and we're not going to deliver the goods.
Within meters of their targets, Ballard's teams in both the Atlantic and the Pacific seem to be lost in the darkness. For 3 days out in the Atlantic, Andy Wheeler and the Irish Oceanographic team have been struggling to reach deep ocean chimneys they're convinced lie just below the maximum operating depth of their ROV. Finally, as the camera tilts down,
oh my God! Oh, you're in it, man.
We're in it. There she goes.
Right. Good.
There it is.
There's the smoke gun.
Oh.
Just incredible. It's 3 years, and there it is. We're eyeballing it. That's amazing. This is just fantastic. All right. This, you get to do this sort of thing once in a lifetime.
Okay.
Once in a lifetime.
Oh, it's just brilliant. Brilliant.
Monster, yeah.
this was previously assumed to be a fairly dull part of the North Atlantic seafloor. Wheeler, Merton, and the team have made a momentous discovery that revolutionizes our understanding of this part of our planet.
Yeah, this is a forest. Oh, beautiful.
Wow.
Oh, man. Absolutely stunning.
Yeah.
Oh, yeah, this
Way. Fantastic.
Over the next 2 days, the team maps a 3-kilometer section of the ridge. What they reveal is a steep-sided valley, and on it, a dense forest of active chimneys. Some are up to 18 meters high.
The seawater that's roaring out of the vents, it's superheated by red-hot magma to over 400 degrees centigrade. Now, what looks like clouds of smoke, well, they're actually plumes of water, and it's packed with chemicals, minerals, and dissolved gases.
Without black smokers, without mid-ocean ridges, without that whole chemical factory, the oceans would become devoid of elements, would become sterile.
That's why the ocean's so beautiful. It's over 3 billion years old and still looking great, at least for the moment. That's because it's always being rejuvenated by this amazing internal circulation system that we only recently discovered.
The team takes rock samples to better understand the chemistry of the vent fluids.
Like a trophy. Like a giant salmon. Oh, not such a giant salmon. That's okay. We're going to cut it up anyway, guys.
It's me that has to keep my hands off fire.
Oh, look at all the pipes in the bottom here. 1, 2, 3, 4, 5, 6, maybe 7 little tubes.
So, Brad, how many people have seen these things? 1, 2, 3, about 8 of us. That's pretty rare.
Okay, so we have these chimneys here. They're pumping out heat, chemicals, and valuable minerals. All right, we know that. But why are there so many exotic creatures living around them? Where do they come from, and how do they survive in what is a really hostile environment?
Across the world, near the Galapagos Islands, Tim Shank and the NOAA team are trying to find out. They've spent 3 days searching a vast, fresh lava flow for hydrothermal vents and life.
Parallel to this wall that we're seeing.
Great, that's great then.
So it's,
okay, the flow does appear to be thicker here than what we saw yesterday. 2 hours ago, we were thinking the dive was nearly over, and we were running out of hope of finding a vent area. You can tell I'm a little excited because we're now sitting here filming this new site. We're seeing crabs and shrimp actively scraping off microbes from the rocks. These are snails. Oh, did you see that? That big puff right there? That coming out, that's spawning. That rifty right there just spawned. We're seeing polychaetes, these are worms, little red worms that are moving along the rocks, also eating what's on the rocks. So microbes are here, that's extensive.
Shank is finding old colonies and new, meaning these hardy creatures can survive volcanic eruptions and establish new colonies very quickly. In fact, this may be the natural cycle here.
This is the Inner Space Center calling the Okeanos Explorer. You hear me? Over. Hi, Tim. I see you on the big screen. So can you tell us what you've been up to over the last several days?
I think we're seeing just the creation events, life coming into these areas following some sort of recent activity, some seafloor type of diking or eruption down there. I could just go on. It's been really, really amazing out here, and this exploration has been fantastic.
Any sense of the length of these cycles? They're decades in your mind?
You know, that's the great question. And to see these clams, I think that they got to be more than 20 years old. I mean, they are really breaking apart. And yet, just less than a meter away, we're seeing vents that look very rigorous and vigorously venting, and small animals are colonizing. It's like the new on top of the old. I would say we're seeing sort of decadal type cycles, maybe even a little bit longer.
Well, I'm sure you're going to hate to have to cut it off, but you'll be heading back tomorrow. Is that your plan?
As Schenk's team finishes up in the Galapagos area, their work points to what seems like an inevitable conclusion: that life thrives on the highly volcanic rock.
So what we're seeing is that this planet is just perfect for life. It's incredible. No matter how extreme or hostile, life seems to be able to get started almost anywhere.
Even in the Antarctic, thousands of meters down on a volcanic ridge, one team is discovering an eerie colony of creatures straight out of a nightmare. Around all the hot hydrothermal vents scientists have explored, life has been abundant, even in the freezing cold waters at the bottom of the world. Biologist John Copley and a team from the United Kingdom are the first scientists to visit hydrothermal vents in the Antarctic Ocean.
We know there is a big vent site here. It's chucking out lots of black smoke that's going up into the water, which we can detect with our chemical sensors that sniff these things out. We found the chimneys, and we found just a lush garden of life at the bottom, covered in tiny little squat lobsters, barnacles, snails. We're now climbing up to the top of the chimneys to see if they're active, see if there's black smoke coming out of the top of them. And there is. There it is.
Yes. These are last year. Yeah, this is shrimp.
Sonar scans of the ocean floor 2,500 meters below reveal a very strange world. A vast rift valley supporting small islands of chimneys, each with discrete colonies of life. At a site dubbed Ivory Towers, the team sees a brand new species. Squat, blind, hairy-looking crustaceans called Hoff crabs, affectionately named for the hairy-chested actor David Hasselhoff. How the crabs can exist here is a testament to the amazing diversity that life can toss up. They survive by growing and eating microbes on fronds that hang from their bellies and claws. To feed the microbes, they fight to be as close to the nutrient-rich, superheated water as possible. Water so hot, it would cook them if they fell in.
They're fighting for space, for access to prime real estate. They're jostling for position over the warmest water with the most hydrogen sulfide. And it's quite a scene. I mean, they're writhing over each other. It's almost terrifying. You could imagine it in a horror movie or something.
At the top of the vent, nearest the hottest, richest water, are the large breeding males. Beneath them, the juvenile males. And at the bottom, the smaller females.
What seems to be critical about all these vent sites is the existence of microbes that can actually thrive in this hostile world. They grow on the barren rock surfaces and they're eaten by other life forms. They're actually the basis of this food chain. But how did they get here in the first place? And that's what we're going to find out next. And I actually think we've located a spot on Earth where we are really seeing ground zero, and it's a very, very primitive landscape.
Halfway around the world, in much more pleasant waters, Ballard is on board his own research vessel near the Greek island of Santorini, in the heart of the Mediterranean Sea. While it looks idyllic, this is actually the crater of a still active giant volcano that erupted cataclysmically 3,600 years ago.
All humans are interested in the violent behavior of our planet. You don't want to be at a spot on our planet where it decides to itch itself. And this is a place where you didn't want to be in 1650 BC. just as you didn't want to be on the slopes of Mount St. Helens when it went. The problem is trying to predict when it's going to do it.
Santorini will likely erupt again, but Ballard believes there is an even greater threat nearby.
You know, everyone that comes here, they focus on Santorini, but the volcano to really keep your eye on is Colombo, just a few miles away. It's much more active, it's much more likely to erupt, and in terms of life, it's a lot more primitive.
Colombo is a submerged, highly active volcano that lies 8 kilometers off the coast of Santorini. The deep interior is isolated from the wider ocean around it. 500 meters down, in almost undisturbed water, is a vast field of unusual hydrothermal vents. These are what Ballard has come to see.
Can we have a ship stop right here? Over.
Yeah, we can camp out here.
The team is measuring the temperature of the water streaming from the vents.
Look at that.
It's a gusher.
Can we break 200?
183, 188, 192.
Yes. Yes.
Oh. 196, 97.
97.
200.
200. Yay.
200.
The research could help predict when Colombo will erupt. But what really interests Ballard are the large mats of orange and white microbes. Little else seems to thrive here. And that is strange.
This is almost a bacterial-driven life system. You're not getting the megafauna. And I think this is what you want to study because it's sort of ground zero. This is the fundamental system on which the other things are dependent upon and flourish.
Ballard's finds reveal that the waters of Colombo are highly saturated with carbon dioxide. Similar, he believes, to Earth's very early oceans.
You have to wonder, I mean, could this be the kind of place where life on Earth began? Did it get its initial foothold here in a world of total darkness, bathed by hot water, saturated with poisonous gas?
The answer to that question may lie in one of the least primeval places on our planet, Los Angeles. Like Robert Ballard, NASA scientist Michael Russell, based at the Jet Propulsion Laboratory in California, is out to show that life could have originated in the deep ocean. But he's doing it in a lab.
All the ingredients of life, remarkably, are focused at this one place on the deep ocean floor. Everything you need, just like, to my mind, everything you need here is in LA.
Russell and his team have built tiny vents in simulated ancient ocean water. They're attempting to recreate the first stages of life.
So you can pretend like this red cap here is the ocean floor. And when you have this syringe full of our hydrothermal fluid that's rich with hydrogen, and it bubbles up, and it comes through this ocean floor.
Russell believes the building blocks of life must have assembled in ocean water like this, when the early Earth was covered with ocean.
There was no land to speak of. It was almost 100% water. It was a very rough place. The day lasted about 8 hours. The moon was extraordinarily close. The waves were huge. There was nothing to stop the hurricanes. We had to be out of the way, right down in the bottom of the womb of the world, so to speak, right down at the bottom of the ocean.
Though Russell's lab has yet to hit the headlines by actually creating life, his experiments may help narrow down the likely locations and conditions of its origin.
So we found these mineral-rich black smokers in the Pacific, the Arctic, Antarctic, Atlantic, as well as other places around the world. But is this really where life actually began on our planet? Or are black smokers just too hot and hostile? Well, these lab experiments are beginning to tell us the answer.
Back in Iceland, in a fjord on the Arctic Circle, Ballard is approaching one likely spot. It's a hydrothermal vent, shallow enough to dive to.
Wow, look at that. My goodness, we're going to hit it.
Roughly 20 meters below Ballard's chartered fishing boat, a towering chimney rises from the depths. Local dive master Erlander Bogerson discovered it only a few years ago.
Wow, look at that. Now, is this just side echoes, right?
No, this is the heat coming up.
Oh, this is the actual...
Yeah, the water coming out, yes, from the bottom, everywhere.
Wow, look at that, just pouring out.
So it's beautiful.
You don't need an ROV or a submarine to get to this vent, but you do need to dress for the occasion. Today, Bogerson is escorting scientists from the University of Iceland to the site. They've been sampling the rocks, vent fluid, and life here in the hope of isolating novel chemicals. A tethered camera gives Bob and researcher Cecilia Omarsdottir a front row seat.
I think this is cool because I'm not freezing to death. Normally I'd be down there freezing to death. This is my, instead of an ROV, I have an ROP, a remotely operated person. The only thing I'm missing right now is a nice bottle of Chardonnay. But look at that guy. Oh, look at those dentures. Did you see how he came in? Yeah. Like, I'm gonna bite you.
It takes not hours, but just a few frigid minutes to reach the vent.
Yeah, there you can see the shimmering water.
Yeah. It's amazing.
Yeah.
The vent water here is clear, not black, because of the mix of chemicals and minerals it contains.
This is the spire, and you can see the shimmering water, and because it's shimmering, you know it's warmer than the ambient water.
The vent water here is a toasty 75 degrees Celsius, but cooler than a 400-degree black smoker. That's because this chimney is further away from the hot magma of the mid-ocean ridge. The lower temperatures make for a different chemistry.
The water coming out of these vents, it's actually alkaline. It's not acidic like the black smokers. And the chimneys like this release chemicals into the water that are the building blocks of organic molecules. And inside the vents are these tiny little interconnected chambers, just the sort of place cells can develop and grow.
This is a good spot for life's emergence, though it's only one of many possibilities.
You know, whether we'll ever nail down exactly where we came from, who knows? But certainly we're getting closer to understanding and narrowing the possibilities and coming up with good candidates of finally finding the smoking gun. Literally, a smoking gun.
But whether life originated in hot vents or cool, Ballard the geologist is convinced of one thing. Life definitely arose from the magical union of hot rock and ocean water.
Don't think of the Earth as, you know, as this sort of this random rock in space. It is living, breathing creature.
In his search to understand why planet Earth is so suited to life, even in the most extreme environments, Dr. Robert Ballard is returning to a truly unique place.
27 years ago, I was privileged to witness a truly primitive event, the birth of new land from a wild ocean. But what I want to know now is, how is life doing on this virgin piece of planet Earth?
The volcanic island of Surtsey, south of Iceland, burst from the ocean floor in 1963. What began as an undersea volcano is now a 1.5 kilometer wide island brimming with life.
Amazing. Look at that. I mean, this is so different. My goodness. It's like I'm on another island. When I was here, this was all barren lava coming out of that crater up there. Looked like that crater. It had no greenery. There was nothing. It was new Earth. This is younger than me. This island is younger than I am. Wow. I would think maybe in 100 years or 1,000 years you could be at this, but the Garden of Eden so quickly. It's unbelievable. It's an amazing process. It's a whole, once you get it going, it just goes and goes and goes. It was primordial landscape. The earth came out of the sea and created new tissue to its surface in a different environment from beneath the sea, and then look what's happened.
Well, here I am quite anxious. This is a new species for the island.
Life is full of surprises. Wow. See the chicks running around over there? I know it's really hard for people to grasp the concept that the Earth is alive. But we're on a creature that's been around for billions of years, constantly changing through its life. And we just can't grasp that time warp.
Ballard and others are convinced that this potent mix of active volcanoes and ocean means life on Earth is virtually guaranteed.
Life is inevitable on this kind of world, absolutely inevitable.
Now we realize that any kind of energy, even energy from the interior of the planet, can support life. It's that realization of the abundance of life and its ability to scavenge that energy for its own purposes, which is really revolutionizing the way we view life and its ability to exist.
It's not a struggle to make it. As soon as the energy was there, as soon as the right conditions were there, it would have onset, or emerged, if you like, to bring the universe, or at least this local part of the universe, closer to equilibrium. So you could say that the rock is our ultimate ancestor.
What's really amazing about planet Earth is because it's a living organism, it has the ability to create all sorts of conditions. They can be hot, they can be cold, they can be acidic, they can be alkaline, they can be up, they can be down, they can be all the different myriad of possibilities that the Earth is operating under as it obeys the laws of physics. And then it says to the spark of life, well, here are all these opportunities. Good luck.